At 25,000 feet, the first superfortresses meet a force no manual can cage. Northern crosshairs creep sideways, the neat timing chains of the bomb run, stretch, and slip. Ground speed surges with a tailwind, then sags into a headwind. The city grid seems to slide under the plexiglass as if Tokyo itself is drifting east. Above the islands, a cold river runs west to east at 100 to 200 miles per hour, and every second a bomb spends falling is another second the river can carry it away. Engines hold their note oxygen, hisses through masks and drift angles, grow past comfortable triangles into ugly long-legged solutions. Navigators chase a moving answer with pencils and grease pencils. Bombardiers dial wind into dials that were never meant for shear like this. Below, searchlights sweep on guesses and flak climbs by feel. Above, contrails shear and fray as the formation fights a crosswind sharp as a blade. The briefers on Saipan had promised geometry steady winds, clean releases, a plant caught in a circle. Over Honshu, the air replies with physics. Then they realize the target isn't a point, but a problem that moves while you aim at it. That the sky can shift 1,000 carefully plotted pounds by city blocks, and that the invisible current, cold, relentless, precise, has chosen the terms of the fight before a single bomb shackle clicks open. They were trying to solve different problems with the same sky. From the Marianas, the Americans needed to turn range into pressure unbroken weekly, if not nightly, until factories' rails and oil centers stopped breathing. The arithmetic looked clean on the briefing chalkboards. A superfortress could reach roughly 3,200 miles on internal fuel and still carry a meaningful load cruise near 300 to 350 miles per hour at altitudes where most interceptors wheezed and ride above the bulk of flak. The geometry of the plan set precise angles, take off from Saipan or Tinian climb to the cold settle at 25 to 30,000 feet, hold formation for the bomb run, trust the Norden to turn airspeed and drift into a point on a grid and come home over black water before dawn. If it worked, you could unhinge an industrial system without landing an army. If it failed, you were scattering steel over neighborhoods and burning fuel to draw lines on a map. The constraints were not romantic, they were mechanical. 4 Wright cyclones made promises, but every promise had a margin. A heavy B-29 leaving a coral strip at night needed usable runway, and a clean climb needed intercoolers to behave in tropical air. Needed cylinder head temperatures to stay shy of the red lines while the superchargers pulled the machine into thin blue. The higher you flew, the colder the oil, the more finicky the mixture, the more brittle the oxygen system became. Fuel tables ruled everything. 3,000 gallons plotted into climb, cruise, bomb run, diversion reserve. A strong headwind on the way home could erase all the cleverness in a briefing. Precision itself was a fuel cost. Holding a tight box at altitude demanded power and patience, and every minute you stayed high with bomb bay doors yawned open was another pound burned and another minute in envelopes the engine men hated. The Japanese problem was the mirror image. They needed to trade time for distance, stretch out the American approach, until the few fighters, the few guns, the thin radar nets could matter. Their strengths were local and specific searchlight crews who could paint a lane in the sky by feel, flak batteries that knew their city's approach corridors, controllers who could read a radar bloom and send what they had toward the right height at the right moment. Their weaknesses were merciless chronic fuel shortages, an interceptor force often out of step with the altitudes and speeds of the threat, and a home front whose factories were dangerously flammable by design, wooden wards, paper screens, tight streets that turned fire into an element with agency. Doctrine 2 was a constraint in daylight climb and slash, at night climb and guess. In winter, everything an aircraft did above Honshu was done inside an invisible river, whose speed some of their meteorologists had measured and wrote down long before the first B-29 came north. At adversary-eye-level, the war felt like arithmetic done with cold hands. In a dim room near Yokohama, a fighter controller leaned over an operator's shoulder and watched a wavering return grow shift and smear with the wind. Ground speed estimates jumped. The height finder answered with numbers that made no sense to peacetime training charts. He pushed a flight toward a predicted point, then scratched it out as the plot slid. The river of air wasn't on his table. It was above his head, curling the intercept geometry into shapes that looked like error. Down the harbor, a searchlight crew tracked by time and guess, counting from sound to sky, knowing that on some nights a beam held a bomber long enough for a battery to throw steel, and on others the beam simply sliced through a lane of wind where targets passed 10 degrees sideways from where they were supposed to be. For the Americans, the first season was an argument between a bomb site and a boundary layer. The Norden could reconcile a steady wind and a steady track. It could not unaided solve a wind field stacked like a layer cake with different shears at different heights. Crews dialed in drift and found the correction valid for 10 seconds, then wrong for the next 10. Navigator fixes came later than the wind. Radar returns painted shapes whose edges moved while you tried to center them. The doctrine demanded altitude because altitude was survival, but altitude also meant longer bomb fall times. Longer fall times meant the wind had more seconds to work on the bomb's path. What looked like a thin wedge on a slide rule became blocks of city on the ground. Then they realized the constraint they'd treated as weather was an engineering limit. You cannot be precise at 25,000 feet in a sky where the crosswind is a third of your ground speed unless you measure the wind. At the exact height your bombs will pass through, and you cannot measure that reliably at night over an enemy city in winter with the instruments you brought. They tried to brute force it, more radiosonde launches, more weather ships, more layered reports, but the jet was not a single current. It was braided, knotted, and mobile. A plan that presumed a uniform wind was colliding with a sky that refused to be averaged. Back in the Marianas, the constraints metastasized into choices. Heavy loads and high altitudes burdened engines and lengthened run times. Long run times, 8 spares and mechanics hours, ground crews crawling in salt air to chase leaks and hairline fractures in a machine pushed into continuous war. The longer you kept the tempo at high altitude, the more you paid in maintenance debt and crew wear. Down low numbers promised a different economy. Warmer, denser air yielded more true airspeed for the same indicated speed. Power settings came down. Engines ran happier, winds were still there, but their vector was a smaller fraction of your ground track. You were closer to the guns and night fighters, but you were finally operating in an envelope your instruments could model without guesswork. For the Japanese, the stakes were civic, not just military. Precision at high altitude threatened machine shops and bridges. Area weapons at lower altitude threatened neighborhoods' fire breaks and the fragile human geography that kept a city alive. A night fighter pilot could gamble his life on a climb and a pass and be done. A fire brigade had to fight until the wind chose to help or stop. The river in the sky was no longer a gift to defenders pushing intercept math. It became a cruel partner to flames, drawing air through districts like a bellows. The very currents that once carried bombs away from point targets could now carry embers across canals. Range meant the Americans could choose. They could accept the penalties of high flight and try to outmeasure the jet, or they could step under it and change what target meant. The Japanese could not choose. Their cities sat exactly where winter made the stream strongest. A plan that assumed altitude as sanctuary had to be rewritten on the fly, and the side with spare engines, spare crews, and spare doctrine had the pen. The first statistic to settle the argument did not arrive in a speech. It appeared in after-action plots showing a circular error probable at altitude so wide that it exceeded the radius of many target complexes. It was not a moral judgment. It was a number, and numbers in this war were policy written in fuel, altitude, and wind. The edge begins as a ratio. If the lateral wind is a large fraction of your ground speed, your precision shrinks by exactly that fraction. If the wind dominates during the bomb's fall, the circle on your map becomes an oval on the Earth. At 25,000 feet, a general-purpose bomb from a B-29 can hang in the air for nearly half a minute. Give the sky 30 seconds and a crosswind at 100 to 200 miles per hour, and you have drift measured in city blocks. The Norden can compute a single wind vector and reconcile it against a steady track. It cannot untie a stacked wind field where speed changes by tens of knots between 20,000 and 30,000 feet. When the Americans tried to ride above flak at 300 to 350 miles per hour, they were flying into a river that sometimes ran at half their ground speed, sometimes more. Precision became a fraction, not a promise. Design was supposed to conquer that. The Superfortress was a system built to make altitude ordinary for Wright R-3350s, with turbo superchargers breathing thin air, pressurized compartments to keep crews alert, a central fire control system to aim remote turrets without dragging gunner cabins through the sky. Everything pointed at height, and height in earlier theaters was sanctuary and accuracy combined. The airplane's numbers were an argument carved into aluminum ranges on internal fuel around 3,200 miles if you treated the throttles with respect, true airspeeds that made the Pacific a knowable distance. But every promise in the engineering carried the seed of the problem. High altitude meant longer bomb fall time. Longer fall time meant the wind owned more of your solution. Superchargers gave you the sky charged interest. Physics did not negotiate. A free-falling body integrates the wind over its time aloft. A 500-pounder leaving a bay at 25,000 feet accumulates lateral error from release to impact. If your wind estimate is off by 20 miles per hour for 10 seconds of that fall, the bomb will arrive tens of yards off. Off by 100 miles per hour for 30 seconds, and you miss by hundreds of yards. Stack an entire formation's bombs under the same error, and a target grid dissolves into a scatterplot. Crews could see it in the drift sites, corrections dialed in cleanly, and then invalidated by a vertical shear you could neither measure nor model from a single altitude reading. The Americans tried to put numbers under the wind. Weather ships pushed into stations, islands launched pilot balloons, radio sondes rose with thermistors and barographs, returning pressure and temperature and wind as thin as wire. The data worked on paper isolines of 150,200 miles per hour, drawn like scars over Honshu, but the stream moved between measurement and mission time. A pattern at dawn could slide by dusk. You could not scoop this river into a jar and weigh it. The pressure gradient that made the jet stream, polar and subtropical contrasts, pressed together shifted like a living thing, and a bomber stream planned to the minute on Saipan found itself nudged sideways over Tokyo by a number that had changed in the hours it took to get there. Logistics tilted the table as well. A mission from Tinian to Tokyo was a long arithmetic problem, fuel drafted into columns for climb cruise bomb, run headwind contingency diversion reserve. Every minute spent at high power to hold a box in rough air drained the columns. Every drift correction requiring a throttle tweak multiplied into gallons across 40 or 100 aircraft. Maintenance crews wrote the costs in their own script intercoolers, balking after long climbs, cylinder head temperatures flirting with limits, oil thickening in the cold. High-altitude precision raids were not just a doctrine. They were a maintenance tempo, an industrial rhythm measured in spares consumed and engines changed. The longer the war stayed in the stratosphere, the steeper the curve of wear. Down low, the numbers flipped. Air density rose, indicated airspeed and true airspeed began to converge. Control response sharpened. The wind vector became a smaller percentage of the track. An 8,000-foot bomb fall is seconds, not half a minute. Give the sky 8 seconds, and the same crosswind can move a bomb, but it moves it less, and an error bar collapses from blocks to streets. The price was obvious. Heavier flak more reachable by night, fighters' turbulence that could bounce a load into a ragged pattern if you let the release go sloppy. But the instruments finally told a steady story, and the bomber became an airplane again, not a blown leaf. When you add in what the targets actually were, wooden wards, light industry spread like tinder, the engineering of incendiaries matched the aerology. An M69 cluster did not ask you to hit a bearing factory, it asked you to seed a geometry of flame. That, too, had a physics. In a dense urban lattice of wood and paper with winter dryness and a modest surface wind, the energy to sustain a conflagration becomes a calculable threshold: how many pounds of jellied gasoline per acre, how close the bomblets must fall to cross-ignite roofs and alleys, how the resulting convection will create its own draft. Where the jet stream punished you for time aloft, a firestorm rewarded you for area and simultaneity. The low-level raid sought to deliver as much incendiary mass as possible in a short window across a shallow rectangle. The wind became an ally that pulled flames together. The same sky that had scattered high-altitude patterns now cruelly helped them burn. Even so, the edge was not just in bombs and altitudes. It was in how many tries you could take to refine the method. Range meant the Americans could come again, adjust headings to account for prevailing winds, change altitudes to sit under the worst shear, and still bring hundreds of airplanes across the same set of coordinates. Radios made the swarm coherent. Radar mapping sets like the APQ-13 gave a coastline and a river and a city outline, even when clouds and smoke erased the world. The Japanese had to guess the window and place sparse fighters into it all while husbanding fuel that grew dearer by the week. The river of air that buoyed a paper balloon to Oregon was the same river that erased an interceptor's climb schedule. Tailwinds and headwinds stretched and shrank the times on which a controller's geometry depended. At adversary-eye-level, the physics narrowed into human frames. A night fighter pilot in a Ki-45 climbing out of Narita watched his rate of closure erupt on one pass and collapse on the next, ground speed flipping as he moved between wind layers. His instruments were telling the truth. His instincts, trained on calmer skies, insisted the truth was wrong. Far below, a meteorological officer folded a pilot balloon record numbers showing 160 miles per hour at 30,000 feet and understood that his city sat under a seasonal machine. He could write it on paper. He could not move Tokyo out from under it. Then they realized that the edge they needed was not mystical, only modular. Treat wind as a fifth engine in the plan, ride it outbound when it helps, refuse it aloft where it hurts, and feed it oxygen when it will fan your fires. Treat altitude as a variable, not a virtue. Treat precision as a tool you put down when the task changes scale. The superfortress was flexible enough to do this. The network that fed it island runways, tanker farms, spare engines, radar vans, radio sonde launches was big enough to test and iterate until the math closed. Numbers became a lever rather than a verdict. A jet stream at 100 to 200 miles per hour was no longer an argument against the campaign. It was a parameter upon which to base a different one. They tried to force the sky into their geometry, and the sky answered with incidents that refused to be outliers. The first long raid to Tokyo had written a strange ellipse on the post-mission plots. The second and third wrote the same ellipse in heavier pencil. Drift corrections that looked clean on the board at Saipan broke apart over Honshu as if a hidden hand were tugging the formation sideways. In debrief tents, navigators put grease-penciled wind triangles next to target photos, and the mismatch was more than weather talk. It was a pattern. Crews described a feeling as physical as turbulence, yet invisible on the gauges, a lateral shove that made the bomb run feel like walking a plank in cross seas. The mission summaries took on a new column, winds aloft by band, and still the numbers would not sit still. In the hangars, the engineering side argued back with metal and schedule. If altitude was the doctrine, then engines must be made to love it. Mechanics crawled through nacelles, chasing leaks that only appeared after long climbs, replacing intercooler seals and safety wiring clamps until their hands remembered the threads in the dark. Turret electricians checked feedback loops in the central fire control system, because if the wind frayed the formation, at least the guns must track cleanly. Bombardiers ran bench drills on Norden tables to shave seconds off their corrections, because if the wind field changed every handful of heartbeats, the only answer was to dial faster. Every lever they could pull was pulled, and yet the map on the wall still showed bombs walking off to the east as if the city wore a magnet. Across the water, the defenders met the same river in a different way. A night fighter patrol climbing out of Narita broke into a laminar pocket where instruments read a climb rate that did not match how the horizon moved. The lead pilot turned for a stern pass on a black triangle and found his timing slipping as ground speed flipped under his feet. Searchlight teams learned to overswing their beams and then bring them back, not because the training manuals said so, but because the target seemed to live a half-degree away from where their ears and clocks put it. An old aerologist, half forgotten on a weather staff, pointed at winter charts and pilot balloon logs and traced a ribbon over Kanto with a fingertip. No one doubted that the ribbon existed. The doubt was about whether it could be used. The first piece of captured evidence lay absurdly light on an American table paper and balsa from a Fugo balloon that had ridden the river east and fallen from a clear Oregon sky. U.S. ordnance officers took calipers to ballast gear and automatic release valves, making a catalogue of enemy work like any other captured kit examination. But the crucial dimension was not a gear tooth, it was a timestamp. The calculated drift across the Pacific matched the winds the weather ships had whispered about. A device meant to start fires in foreign forests became an admission written in cloth and cord that there was a highway at altitude reliable enough to navigate, strong enough to count on. Intelligence officers, not content with wreckage, added translations of Japanese aerological bulletins to the pile tables of winter westerlies, notes on seasonal maxima. The artifacts and the papers argued the same case. The river was no rumor. Field tests began as footnotes and grew teeth. A group was told to hold 20,000 feet on a trial run, then 15, to see whether the jet's claw loosened. The briefers were careful with words. No one wanted to sound as if doctrine were on trial. But the instruments did not care about doctrine. Radar scopes at medium altitude showed coastlines less smeared by smoke and shear. APQ-13 outlines steadied. Navigator fixes lined up with dead reckoning like old friends who had stopped arguing. At lower heights, the wind still bit, but it bit less, and the bombs fell after seconds instead of long elastic half-minutes. Debrief boards sprouted two circles, the elongated oval from high-altitude HE and the tighter scatter from the low-level tests. The distance between the two shapes was not theory. It was a walking tour across a neighborhood instead of a whole ward. The interim admission, when it came, was quiet and practical. Weather annexes to operations orders began to state altitudes not as a default, but as a variable chosen against the wind field. Loadouts shifted toward M69 clusters for urban targets even on nights when the wind charts looked friendlier because the reality aloft had outfoxed the promise on paper too many times. Crew chiefs noticed a different fatigue when the mission stepped under the stream, less frostbitten oxygen gear to fix fewer reports of gun turrets sticking in the cold cylinder, head temperatures that no longer menaced the red lines like a metronome gone mad. Maintenance hours per flight hour stopped climbing. A system built to live at the ceiling discovered it could fight harder an octave lower. The defenders adapted in their own tempo. Fighter controllers began to bracket likely approach boxes not only by course lines from the Marianas, but by nights when the lower winds would favor interception climbs. Searchlight teams trained to hold a point and let the target pass through the beam rather than chase it, an odd technique that made sense only in a sky where lateral flow was a constant partner. Flak batteries adjusted fuse settings after studying drift on their own bursts, relearning lead angles because the ground track of a bomber at 8,000 feet under a winter stream is not the ground track of that same bomber 4 miles higher in clean summer air. Yet the trade was cruel. The very shift that brought attackers within reach also shifted their aim from foundries to districts, from camshaft sheds to homes. Somewhere in this sequence of experiments and replies, a staff change put new hands on the lever. The method gained a champion who treated altitude as a setting, not a sacrament, and who could translate those post-mission plots into orders with fewer caveats. The first full-up execution of the new logic would come later in a night of heat and ash that would shock even those who had built the plan, but its bones were laid in these rising incidents: a balloon's trans-Pacific drift, a captured table of winter winds, a medium-altitude trial that drew a tighter ellipse on a map, a maintenance log that stopped screaming at the cold. At adversary-eye-level, the recognition felt like losing an advantage that had never really been yours. A Japanese radar officer on a February night watched returns stack thicker and lower than before and understood without anyone telling him that the defense was about to get bloodier and less effective at once. Lower made his fighters more dangerous. Lower also made every street more flammable. He had taken comfort in the jet's power to scatter bombs away from point targets. Now he saw how the same winds would feed what the Americans had decided to bring. Far below, a fire brigade captain drilled his crews on bucket brigades that would fail if the wind turned alleys into chimneys. He did not need a weather map to read the new arithmetic. He could hear it in the draft that ran at the mouths of canals. The final proofs before the turning point were unspectacular and decisive. A short, sharp raid at medium altitude lit more roofs than a longer, high-altitude effort had managed in weeks. A training film hastily recut emphasized radar fixes over visual aiming timing, over formation geometry, fuel economy, over heroic climbs. In Saipan briefing huts, the word precision stopped sounding like a promise and started sounding like a choice you make only when the sky agrees. The river above Japan still ran at 100 to 200 miles per hour, where the winter laid its strongest pressure contrasts, but the bombers no longer had to live inside it to do their work. The incidents had risen in a clear line, each one adding weight until the scale itself tipped. They made it work not by discovering a trick, but by sanding the plan until it fit the sky. Reliability came first, because nothing about the new method mattered if the machines could not meet the schedule. Crews who had learned to fear 1,000 small failures at the ceiling, icing building in lines, oxygen fittings that hissed at the wrong moment, electric turrets that sulked in thin air, found that the airplane behaved like an airplane again, at working altitudes. Engines ran warmer and cleaner. Intercoolers stopped being the villains of every debrief. The red lines on cylinder head gauges no longer felt like cliffs. Maintenance chiefs on Tinian could see the doctrine in their ledgers. Hours per flight hour stopped climbing. The stack of grounded aircraft shrank enough to make tempo real. Turnaround drilled itself into muscle memory. Fuel Bowsers, bomb trucks, oxygen carts, radios, checked radars, tuned a practiced ballet under floodlights, and the machines came back ready to go again before the weather could change its mind. Training followed the machinery. Bombardiers who had spent months worshipping at the altar of the Norden were retrained to think in rectangles and timing, to treat a city not as a single point, but as a shallow grid that you seed with fire. They rehearsed at night over water, with blackout coastlines, learned to trust the dull glow of the APQ-13 painting a crescent of bay and a river's spine through smoke. Navigators relearned fixes by rhythm beacon, coastline bridge shadow on radar, a clock, a course change, not because the old skills had failed, but because the new envelope demanded cadence more than finesse. Pilots practiced bomb bay door discipline and throttle changes that held a stream together without ragged surges. They learned that order was a weapon. 100 aircraft arriving in a pulse is physics. The same 100 strung out by poor timing is waste. Radios stitched the change together. The old precision doctrine had been a choreography of boxes and leaderships, a geometry that punished deviation. The new doctrine was a swarm with a spine. Air-to-air calls were clipped, and few mostly timing nudges and course confirmations. Ground controllers at the Marianas and weather ships along the lane fed winds fronts and cloud tops to a living plan, adjusting takeoff waves to meet windows where lower-level turbulence would bruise but not break, where surface winds would feed fires rather than blow them apart. The stream overhead still howled. The stream below was manageable. Doppler drift meters and radar altimeters gave crews the simple truths that mattered: how fast over the ground, how high over the roofs, and the rest of the noise was stripped away. Fuel, always the quiet tyrant, became less tyrannical when altitude gave way. The same gross weight launched into denser air needed fewer inches of mercury and fewer RPM to hold formation. The long climbs eased. Mixtures sat in friendlier zones. Planners could load more incendiaries or more reserve into the same envelope and still keep a cushion against headwinds home. That cushion unlocked a freedom the high-altitude regime had been stealing: the freedom to loiter long enough to sort into a clean stream before the bomb run, to accept a vector change, to sit under a shear layer, to run the throttles conservatively and bring the engines home in a mood to fly tomorrow night. Reliability fed fuel economy fed tempo, tempo fed pressure. Doctrine sharpened until it could be written in a few lines that everyone understood at 3 in the morning. Go under the worst of the jet. Choose nights when surface winds favor the burn and sea-level humidity won't smother it. Seed the rectangle quickly. Avoid climbing into shear bands during the run. Let radar give you the city's bones and steer by bones when the skin is smoke. Recover low, cold, and boring. The language was plain because the sky was complicated, and the only way to win that kind of argument is to make your own part of it simple. On the other side of the water, the doctrine adjustment was a bitter education. A Japanese fighter section briefed to meet a high box at altitude now found itself scrambling into a lower fight where instruments lied less, but time lied more. Tailwinds on the outbound leg shortened the intercept window. Headwinds on the return lengthened it into fuel fear. Controllers in dim rooms near Kawasaki and Nagoya tried to learn the new cadence of American raids that were less like parades and more like storms, shorter, denser, nearer the ground, with the radar picture fat and noisy until it was suddenly empty. Pilots in twin-engined Ki-45s and Ki-46s reported closure rates they could believe again, only to discover that the aim point had shifted from a hard shed to a city that could not be moved. They were more dangerous in the pass, but their passes mattered less to the outcome. At street level, the difference was a doctrine that attached to wood and oxygen. Fire brigades knew their districts like families, the way a canal could become a wall and then a fuse, the way a lane could drink wind and scream. Training that once emphasized bucket relays and roof teams against a single strike now had to face a carpet of small ignitions arriving within minutes of each other. Sirens lost the race with the physics of heat. Searchlight crews who had learned to hold a beam steady and let a bomber walk through it kept doing their jobs. But the fight below their lights was no longer one of tracer and altitude. It was one of drafts and roofs. The river of air overhead, which had once gifted defenders with dispersion, now poured itself through windows and doorways and fed the very thing the attackers had brought. The new method's success depended on 1,000 unromantic checks that turned risk into routine. Crew chiefs caught a glitch in a bomb bay door actuator on a warm-up run and fixed it before it could cost an airplane at 8,000 feet in turbulence. Radar operators ran their own bench tests with photographs of Tokyo's coastline taped over cathode faces so that their hands could find the same shapes when the glass filled with noise and ash. Weather officers built a local language for the jet's moods nights when the core sat over Kanto like a knife nights when it sagged into the Sea of Japan, and that language appeared in short, blunt lines on the ops board: low band, strong surface winds, favorable go. Everyone on the line learned to read those lines without the decoration of speeches. There was still fear in the plan. Doctrine does not erase flak at 8 to 10,000 feet or the sharp, predatory streak of a fighter rising out of blackness. But even fear receded from that paralyzing systemic kind fear that the sky itself was unmodelable into the pragmatic kind that crews had trained to manage. Gunners could see their tracers hit the right piece of dark at the right distance again. Pilots could taste when the airplane was inside its designed envelope, not hanging by its props on the margins. Bombardiers could watch a rectangular pattern of fires bloom on a scope and know that the seconds of the run had been spent well. The system replaced wonder with work. Then they realized that the river above them could be used as a schedule. Tailwinds outbound meant earlier TOTs and tighter stacks of arrivals. Headwinds home meant more conservative loads and altitudes chosen to spare fuel. Weather that punished climbouts to the ceiling now became merely a gust line to cross. The jet stream stopped being a curse or a charm and became a column in a plan: 20 minutes to the IP if the core is low, 15 if it's high. With that column came a kind of moral clarity within the machine culture. No one pretended the sky had changed. They had. They had stopped asking the wind to validate their doctrine and started asking their doctrine to accept the wind. Adversary-eye-level makes the transformation visible in a room no camera sees. A Japanese radar officer leaning into the scope on a March night, the trace thicker, closer, and more numerous than the winter's high raids, the sweep returning in brighter blooms over the city's center. He keys a phone and his voice is steady, but his eyes flick to the wind readings at the edge of the board surface. 8 to 12 from the northwest, and he knows those numbers will not help him. They will help the enemy's fire. In a firehouse a few wards away, a captain ties a scarf against the smoke and feels the draw across the threshold, a steady pull that turns an open door into a nozzle. He counts the seconds between new ignitions and understands that the attack's power is not in any single impact, but in a saturation that makes his crew's training feel suddenly ceremonial. On a runway in the Marianas, the doctrine reduces itself to the simple, repeated gestures that win wars. A crew climbs a ladder and checks masks. A chief slaps a nacelle and looks at a mechanic who nods because the leak that might have been a story tonight is already fixed. In a briefing hut, a weather officer underlines a wind arrow once and says little. The pilot reads the line, reads the map, and reads his crew's faces. None of them are surprised by what the sky will do. Surprise is the enemy of reliability. They have traded it for rhythm. By the time the plan is fully mature, success looks like inevitability. It is not. It is the additive weight of design used inside its envelope, training tuned to instruments that tell simple truths, radios that carry just enough information at the right time, fuel margins that buy choice, and a doctrine rewritten to treat the air's rivers as facts rather than enemies. The jet stream still runs at 100 to 200 miles per hour, where winter draws the pressure lines tight over Japan. It still has the power to scatter, to trick, to kill, but it no longer decides the shape of the bomb pattern. The people do the ones who learned its language and wrote a new grammar on top of it in chalk and then in fire. The turning point arrives first as a number on a staff table, not as a roar in the night. In a cramped room on Tinian mission, plots from the winter's high-altitude raids are pinned edge to edge, each one a rain of impacts, skidding away from aim points like iron filings brushed by an unseen magnet. Someone has drawn a circle around the target complex and another circle around the median impacts. And then in pencil the ratio that matters, the winter circular error probable at 25,000 feet over Tokyo, is more than twice the radius of the target. That is not weather, that is arithmetic. The room goes quiet in the way rooms go quiet when a belief dies. Altitude is not accuracy here. Altitude is dispersion multiplied by time of fall in a river of air that does not care about doctrine. The lever moves. On the other side of the water, the realization takes a human face. A radar officer near Kawasaki has spent months learning the cadence of the high raids, thin returns at altitude, long approach, times a geometry that gives him a chance to place a handful of fighters into a workable intercept window if the winds are kind. He watches the sweep on a March night and sees the picture change. The returns are fatter, lower, more numerous, the belt of them strung across the city like beads poured from a jar. He reaches for the phone with a hand that does not shake, but his eye catches the wind strip at the edge of the board surface, 8 to 12 from the northwest, steady. It will feed fires. He speaks the words he has always spoken, headings, altitudes, bearings, and knows that their meaning is about to be different. The inflection is not declared, it is flown. The stream still howls up near the tropopause, 100 to 200 miles per hour, where winter squeezes pressure lines tight, but the bombers step under it and refuse its terms. The climb is shorter, the engines are less pained, the navigator's clocks keep cadence across a sea the color of lead. There is no high box to hold through an invisible sawtooth. There is a pulse to make at 7,000 to 9,000 feet a rectangle, to seed quickly a return leg to husband through headwinds that no longer threaten to erase the reserve. The first hard metric has already been set on the wall, CEP greater than target radius times 2, and with it the corollary that makes sense to crew chiefs and bombardiers alike. If the sky refuses point precision, change the scale of the point. Over Tokyo on the night of 9 to 10 March 1945, the decision stops being chalk and becomes heat. The city's bones show on radar a bay, a river, a grid, and the first ships ride their timing marks into a rectangle that cartographers have shaded for wood and paper, for the tightness of streets and the emptiness of fire breaks. Doors open. The new load is not a promise to a machine shop, it is a proposal to oxygen. Bomblets spill and bite, and the air answers with a draft like a living thing. In an instant, the doctrine's gamble is visible in 1,000 places at once, roofs igniting not as isolated scars, but as a chain reaction, alleys becoming channels that breathe. The sky above is still ruled by a river. The Americans decided not to fight at altitude. The streets below are ruled by a river they have chosen to feed. At adversary-eye-level, the moment is a recalibration of instinct. A night fighter pilot in a Ki-45 rises into a fight. He thinks he understands at last altitudes he can reach closure rates that match the practice graphs on his ready room wall. He earns his pass and finds the black triangle less mythical and more vulnerable than the high contrails ever were. The pass is clean, the traces feel right. He banks for another and watches the city shift from shapes to waves. The heat is not smoke alone, it is draw. The streets are drawing air. The bomber stream is shorter than he expected, denser than his controller predicted, and already turning away. His own fuel sheet is not the tyrant it was at the ceiling, but the numbers have betrayed him in a different way. The timing window is a fraction of what it used to be, and the effect of the raid is no longer arrested by missing a factory roof by 3 streets. The raid has climbed under the wind and then climbed into it in a different form. On the ground, a fire captain opens a door, and the building breathes at him like an animal. He can map his ward with his eyes closed, the canal that can stop a burn, and the alley that will turn into a fuse, and still the physics outrun him. A gust at street level takes embers across the gap that training had promised would hold. He turns to send a crew 3 houses down, and the 3 houses are already urgent. The jet high overhead is no longer a defender's accidental ally, dispersing bombs away from points of pride. It is a bellows for what has been lit, a pressure gradient made visible in the tilt of a flame. In Saipan debriefs the next morning, the word that recurs is not victory. It is confirmation. Instruments that had been arguments are now witnesses. Radar scopes that smeared at altitude returned coastlines and river bends that matched the plan. Drift meters that lied to the eye at 25,000 feet told usable truths near 8. Fuel tables that had been cliff edges became slopes with room left at the bottom. The crews speak in numbers because numbers have given them back control times from IP to release seconds of door open at speed indicated airspeed held within a tolerance that keeps the stream coherent. The hard metric that killed the old promise, the ratio of CEP to target radius, has an answering metric now that blesses the new 1% of built-up area burned per ton under the chosen wind and altitude. It is ugly in its clarity. It ends arguments. The defenders realize in the way defenders always do, by subtraction. Subtract the time a controller once had to vector and climb. Subtract the refuge of a winter wind that used to steal aim points to the east. Subtract the meaning of a single successful pass. Subtract the ability to rebuild a machine shop when the ward around it has become fuel. They still fight. Searchlights still find machines, and flak still punishes errors, and fighters still carve courage into the night, but the geometry has changed. The stream overhead is no longer a gatekeeper, it is a backdrop. The thing that decides outcomes is now below it, a series of choices aligned with physics instead of defying it. The inflection continues across months until it feels like a climate, not a weather event. There are other raids and other cities, Osaka in June, then a chain of nights when the monsoon and the jet play seesaw and the planners ride the hinge. The pattern keeps vindicating itself: altitudes chosen to sit under shear loads, chosen to match roofs and streets, timing chosen to make simultaneity returns, chosen to spare fuel and engines for tomorrow. The jet stream still matters. It's in the briefings as a tailwind you ride outbound and a headwind you price into your reserve, a column in a plan instead of a gamble against the sky. By summer, the adversary's realization is complete and bitter. The quote from the old meteorologist, once a curiosity in a file, has become a sort of epitaph for a season in which physics had the final vote. The home defense network can adapt tactics. It cannot move cities out from under winter's river of air or rewrite the material of their construction. The hard metric that pivoted the campaign, the doubling of CEP beyond target radius at altitude, has been replaced by another number that no anti-aircraft battery can fire at the probability that a district of wood and paper ignites across streets when a given mass of incendiary falls in a given time. The country's survival rhythms now live in wind reports and humidity readings, and the calendar things the men in rooms can read, not things they can command. Back in the Marianas, the turning point registers in smaller ways that matter more. The maintenance logs flatten. The spare engines move in and out at a pace that mechanics can endure. Crews walk off runways, tired from work, not defeated by a sky that turned instruments into riddles. The doctrine that came out of a number has become habit, and habit decides wars because it makes success repeatable. The stream over Japan has not stopped running at 100 to 200 miles per hour, where the winter sets its gears. It has simply stopped deciding the geometry of the fight. The people have taken that job back from the wind. And so the climax is not a crescendo, but a retuning. A campaign built to live at the ceiling, to sanctify precision, absorbs a fundamental truth and survives by changing. A defense that once drew comfort from winter's invisible ally sees that ally conscripted to the other side. The hard metric that killed one doctrine gives birth to another, and the moment of realization is a man in a Japanese control room looking at a sweep that is all city and knowing that his maps are now insufficient, and a man in a Marianas briefing hut underlining a wind arrow once and knowing that his map is finally honest. The opening shock returns, but now it has an answer. Bombs no longer slide under an invisible hand, because the hands on the throttles have chosen a different layer of sky. In the end, the consequences were logistical before they were moral. The machines began to last. Engines that had lived on the cliff edge at the ceiling settled into repeatable cycles. Maintenance hours stopped climbing like a fever. Sortie tempo became a calendar instead of a gamble. Range, once a brute fact that enabled a plan, became a lever that tuned it. Nights chosen for surface winds that would feed a burn, altitudes chosen to sit under the shear where instruments told the steady truths crews could use. Industrially, the result was decisive cities that had been point targets on posters dissolved into systems that could be broken by rhythm, and the rhythm held until there was nothing left for it to break. For the defenders, adaptation never caught up with arithmetic. Night fighters learned to make cleaner passes. Flak learned new fuse settings for lower tracks. Searchlight crews learned to hold a point and let the stream carry a silhouette through the cone. But the old comfort winter's invisible hand scattering the bomb line off a factory roof was gone, and in its place the same air became a bellows in the streets. The war did what wars always do. When technology and weather make an alliance, it moved faster than the people inside it could. What changed next was the map on every planner's wall. The jet stream, a rumor made of equations in one war room, and a quiet line in a Japanese bulletin 2 decades earlier became a permanent layer in global aviation. Airlines learned to ride the river and price its schedules, written with tailwinds as assets and headwinds as debt. Weather reconnaissance grew, teeth radio sondes, high-altitude aircraft, later satellites, because no one would again plan a campaign that presumed a sky it had not first measured. Doctrine absorbed a new humility. Altitude ceased to be a virtue in itself. Precision ceased to be a promise detached from wind and fall time. The instrument panel's beauty was recognized as conditional, a language that needed the air's consent. The lessons followed into other rooms and other wars. Bomb plots became wind plots. Missile guidance tables grew columns for aloft vectors. Navigators taught cadets that a steady wind is a fairy tale unless you can prove it in layers. In the long peace between storms, the civil world took the same truth and made it mundane. Dispatchers drawing arcs that shave hours off crossings. Pilots reporting ride at flight level 390 like mariners swapping currents. A seasonal machine that once shredded a doctrine became a river every commuter has flown. At adversary-eye-level, the legacy remains a particular feeling on a winter night. A Japanese veteran standing by a river in Tokyo when the air is knife-cold and the breeze at street level hums in narrow alleys. He watches breath drift east and feels the old draft tug at his scarf. He remembers screens that bloomed and swept, searchlights swinging a half-degree wide, a city that breathed like an animal when doors opened. The fight ended long ago, but the physics never did. The wind does not remember which side you were on. So the story closes where it began, with an invisible hand moving steel sideways in the dark. The difference is not in the wind, it is in the people who learn to stop asking it for permission and start reading it as fact. The night is still brittle and loud, in-memory tracer lines still sketching on slate. The river still runs west to east above winter Japan. Once it stole the aim before gravity could. Later, when the plan stepped under it, the aim changed shape and the river became a line on a chart. The lesson endures like cold in a war of machines. The air itself is the oldest machine, and the only winning doctrine is the one that treats it as real.